Hi everyone, welcome back. In this lecture, you will create the Docker Compose files to create and run a Kafka cluster in your local Docker environment. To start adding Kafka to system, let's first add Docker Compose folder and then add the required Docker Compose files to create Kafka cluster using Docker locally. So I will create a folder Docker Compose here and then add 3 files: common YAML, Kafka cluster YAML, and environment. Let's go over these files one by one. The common YAML has the common network driver type. When we run a compose file, we include this common file, so it will set the network type as bridge. In Docker terminology, a bridge network uses a software bridge, which allows containers connected to the same bridge network to communicate, while preventing other containers to reach the network. Containers on different bridge networks cannot communicate directly with each other, since the bridge driver creates rules to prevent this communication. If you don't set a bridge network, a default network will be created. And on the default bridge network, containers can only access each other by IP addresses by default. But with a user-defined bridge network, containers can be resolved using hostnames, which is more handy to use instead of IP addresses because IP has a dynamic structure and can change in time. In the environment file .env, we define the versions of the images in a single place. Also pass the network name and can pass all of the other common variables. For example, this global network is used in all compose files so that they can reach to each other, because we want to reach all the containers we run. Here please check the service version from the pom.xml file and be sure you have the correct project version set to the service version environment variable. Coming to the Kafka cluster YAML file, we see that we have one Zookeeper, one Schema registry, and 3 Kafka containers defined. Zookeeper is required to hold metadata for a cluster and play a role on determining leader election and cluster health. But I want to remind you that in the coming releases of Kafka, Zookeeper is planned to be removed. It is early 2021 with key IP 500 project. And then the leader election will be done inside Kafka cluster itself, where the leader itself is responsible for the cluster health. Schema registry is used to register a schema for a Kafka topic, and it will check the producers and consumers each time to force them to use the registered schema so that only the allowed schema will be used. Producers and consumers check schema with ID and cache the result before sending and receiving data. So it is actually a one-time request to the schema registry and then subsequent checks done by using cache. Schema registry also allows backward and forward compatibility, so schema can evolve without breaking changes. Finally, as I said, we have 3 Kafka containers defined here in the Kafka cluster YAML file. Each use the same confluent Kafka image, while the ports are different. First of all, why do we have 3 containers, which is actually 3 Kafka brokers? It is to accomplish the concept of quorum, which indicates the minimum number of members necessary to conduct a business in a group. And in Kafka terms, this will prevent split brain issue, which can occur when a network split occurs. It simply prevents creating more than one network in a group of Kafka brokers, such that with 3 brokers, a network must have 2 nodes at least. This way we can be sure that only one network can be created, because there can only be one group with 2 nodes. Note that the other group will have only 1 node, which is not enough to create a network. Alright, coming to the properties in the Kafka broker service definition. We basically set a unique ID and then set the Zookeeper URL, which is necessary to reach to Zookeeper for metadata and organization. as we mentioned previously. And then we also have the listeners here. Note that we have two listeners, one for internal communication and one for accessing the cluster from outside of container, which will use the exposed ports. For example, this exposed port is 190.92 for the Kafka broker 1. That means we can reach this container from outside using localhost or the name of the machine that Docker runs and on port 190.92. While inside the Docker, we will reach to this container using the hostname defined in the compose file, which is Kafka broker 1. And for port, we use 1992 for internal communication. Finally, we define the compression type as producer here, which is the concept of compressing the data end-to-end, as we talked on the Kafka and the producer section. Alright, let's now run this compose file and check if all containers are running using docker ps command. First, we will use command docker compose -f common YAML -f Kafka cluster YAML up. Then, after waiting a bit, we can run docker ps command to see if containers are really running. Great, now I want to introduce you with a command line tool called KafkaCat, which is an easy tool to monitor Kafka cluster and topics. I prefer to use standalone KafkaCat utility on Mac machine, which we can install with brew install KafkaCat commands. While for Windows, it's better to use KafkaCat Docker image. Please check here to learn how to run KafkaCat Docker image locally. The important thing to use KafkaCat with the Docker image is to use the network host option, because when we use KafkaCat inside a Docker container, to be able to reach to the host machine, that is localhost in our case, we need to start the container by including it in the host machine's network. So we can use this Docker command by setting the network host option and query the Kafka cluster that is running in our computer. Now I will run some basic KafkaCat commands to monitor the cluster that we are running using Docker image. Let's run KafkaCat -l -b localhost 190.92 command. Here -l stands for list and -b stands for brokers. So after -b, we specify the broker host and port, where we define this port on compose file for connecting to cluster from outside. As you see, we see the list of brokers here, as well as the topics, which are some internal topics. Alright, enough talking. I promise you will write more code starting from next section. For now, I will just create a submodule Kafka and create 3 submodules: Kafka model, Kafka admin, and Kafka producer under the Kafka module. So to better modularize Kafka-related codes, I created and used submodules that do different jobs. Kafka model will create and hold the Avro model that will hold the data that will be inserted into Kafka. Kafka admin will create Kafka topics programmatically and also check if topics are created. And Kafka producer will include the Spring Kafka dependency and related implementation that will help you to write the logic to insert the data into Kafka topics. Great! We will continue with the implementation of those modules in the next lecture.